Vertex form of a quadratic is, but what does that really mean? Okay, first I want you to recognize this a right here. That's the same a value as when we talk about a standard form equation. So using what you know about polynomials, write the following quadratics in standard form. So we're giving them to you in vertex form, and we want you to write them in standard form. What would we do on A? Well, this is a square of a difference. So you can use the pattern, or if you need to, you can expand it and then FOIL. Okay, take a moment if you need to FOIL. Okay, so this would be y equals x squared minus 4x plus 4. We could take this, and since this is the same as this right here, we would put that right here. Now on B, we have a square of the sum. So again, if you need to, go ahead and expand it and FOIL. But we know the pattern. We know it would be x squared plus 6x plus 9 minus 1. And then we would combine our like terms right here. We could put that down here. The last one is a little more involved. We have an a value that is not 1, so we'll have to pay attention to that. We have y equals negative 3 square of a sum. If you need to, go ahead and expand that so you can FOIL, but if you know the pattern, x squared plus 4x plus 4. But this plus 4 is still over here. So now what do we do with that a value? We're going to distribute the a value to every term. So we get negative 3x squared minus 12x minus 12. The plus 4 is still there. And then we combine our like terms. And we can put that down here as our standard form of the same function. So the question is, what are h and k? In vertex form, it says x minus h. So if this says x minus 2, then the value of h is 2. If this says x plus 3, then what do we know about the value of h? It would have to be x minus negative 3. So my value of h is negative 3. This says x plus 2. So same thing. What is h? If it's x minus h, it would have to be x minus negative 2. So negative 2 is my value of h. What is my value of k? If it doesn't say anything here, this is like saying plus 0. So my value of k is 0. If we have minus 1, but remember it says plus k, so my value is negative 1. Plus 4. Let's remember how to find the vertex from a standard form equation. X equals negative b over 2a. So if I'm looking at the first one, negative b would be 4 over 2 times 1. Well, that equals 2, so my vertex is 2. Plug in to get y. So we say 2 squared minus 4 times 2 plus 4. 4 minus 8 plus 4, 0. Negative b over 2a equals negative 3. Are you starting to see the pattern? If I plug in negative 3 squared plus 6 times negative 3 plus 8. 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. And for C, negative b would be 12 over 2 times negative 3, so over 2 times a. That equals negative 2, 4. So what do we notice about H and K? This is the vertex point. So without having to put it in standard form, I should be able to use vertex form to identify what the vertex is. So if H is my x value, x minus negative 4 gives me x plus 4, so negative 4 is my H, and my K would be negative 2. Okay? And that's going to be important when we talk about transformations. Okay, so for the second part of this investigation, you may want a calculator if you have one handy. If not, you are always welcome to go onto Desmos.com, and that can help you visualize the graphs that we'll be looking at today. So for each of the following, graph the parent function and the given quadratic in your graphing calculator. In a different color, sketch the given quadratic in the coordinate plane. The sketch of the parent function is done for you. So in your own words, describe the change that occurs compared to the parent function. You go to y equals, and we plot the parent function. So for the parent function for a quadratic, remember that's x squared. And the first one that we have is 2x squared. So I'm going to type in 2x squared. When I go to the graph, I see here parent function, first one, and the second one is on the inside. So I'm going to sketch that in my work where it's inside. All right, now how would we describe this change? What happened to the quadratic? Well, I would say, okay, it started out like this and then it got skinnier. So I might say skinny. You could say narrower. Okay. Now, if we go back to y equals, notice this one says 1/3 x. So I'm going to put in my fraction of 1/3. I'm going to delete this one. And when I look at my graph, here is my parent function again. And now here is my second function. What happened there? Well, it got wider. Okay, and I'm going to sketch that on my graph. So there we have talked about what was changing. Well, this is the a value. We described how we changed the a value when a, which in the parent function, what is the value of a? In the parent function, the value of a is 1, right? So if I were to say, okay, well, when a was bigger than 1, the quadratic became narrower. And when we look at the value of a being smaller than 1, or less than 1, my quadratic became wider. Let's look what happens when we change the sign of a. So we're still keeping our parent function as the first one, but my second one, we're talking about -4, and then let's delete the fraction. Here's the parent function, and here's -4x squared. So here we ended up with something that was not just skinnier, but also opening downward. Okay, so that's to think about that. When we see the second example, y equals -0.75, x squared, and we graph that. And here's our parent function. And it's still downward. And it's a lot closer, but you can still see how it's a little bit wider on the bottom one. So I'm going to make it just a little bit wider. So on these we have opens downward, but also it is narrower. On this one and on this one we have opens downward, but this one is wider. So what happens when A is negative? A is positive, our quadratic will open upward, like in our first two examples. And when we have a negative A, our quadratic opens downward. All right, so in the back of this, so I'm going to do the first two examples with you, and then you can look on a graph how these other three, and then check on the key if you agree with the description of the changing value of H and the changing value of K. Then we'll talk about how to identify all the transformations that happen here. So let's look at the changing values of H and K. Remember that H is the x value of the vertex. So think about how that might react in the function. So if I have my parent function, keeping it there, what if I say x minus 2 squared? So this is changing the x value of the vertex. Well, what's the x value of the vertex? What is the value of H here? Well, H would equal 2, because remember, vertex form is y equals x minus H squared plus K. So let's look at what that looks like on the graph. Here is our parent function. And look where that ended up. It looks almost the exact same, except that it has been moved 2 units right. So on your own, look at the changing values of H for the next three. Okay, so we can pause the video and you can do that. And then when you unpause, we'll check. All right, so I made the mistake of not putting in my negative at first, so if you see that, that's what happened here. But check what we are looking at. So when we talk about H, when we change the value of H, if H is positive, so H is positive, that means that what we're looking at in the function is an x minus H value. We move right, however many units it tells us. But if H is negative, like we're looking at x plus H squared, then we are moving left. And in the last two examples, you saw what happens when you have a changing value of A being greater than 1, A is less than 1, and also negative. So we are talking about opening downward and wider. Okay, so remember that that was for H, which was the value, the x value of the vertex. So what happens when we change K? K is the y value of the vertex. So if we tell this is plus 4, what do you think is going to happen? There it is. And then what do we see here? It's moved up 4 units because the value of K is 4. Moved up 4 units. Now here it looks like it's wider, but it's not actually wider. Remember when we talked about the parent function, over 1, up 1, over 2, up 4, you would find the same here when we're comparing it to the parent function. Okay, so using that, think about how we would see changes for the next 3. You can pause the video and then come back and look for the answers. So looking here, when we change the value of K, what we're really looking at is if a positive k, so positive k, our quadratic will move up. And if we have a negative k, we say it moves down. Okay, so the possible changes here are what happens to A, what happens to H, and what happens to K. A can be positive or negative, it can be greater than or less than 1, H can be positive or negative, and K can be positive or negative.